Hi, I'm GUO CHENG GUANG, 15 years old, secondary 3 for NS High School. In this lesson, we'll be taking a look at physical chemistry. So, for our previous few lessons of physical chemistry, we talked about Raoult's law and other different things you can go by to take a look at. So, we did make some comparisons in previous lessons. So, in this lesson, we'll take a look at another comparison. And this time, it is a comparison between two different types of concentrations. And the first type of concentration is molarity. The second type of concentration is molality. So what types of concentrations are these for? Since the concentrations you can have for many different types of things. So these two are mainly for solutions, okay? So solutions is you have two different things mixing each other. At least one of them is a liquid, alright? So let's take a look at what is so different between molarity and molality. So from up here, you can already tell that they have one character in difference, which is an R and an L, and of course, their symbols. So here, molarity, you use capital M to represent it, while for molality, you have a small m to represent it. So how about let's take a look at the definition for each of these first. So how do you calculate molarity? Molarity is when you find the number of moles of solute. So this is the number of moles of solute dissolved in 1 liter of solution. Alright, so this is molarity. It is when you find the number of moles of solute that are dissolved in 1 liter of the solution that you have. So how about molality? Now molality, it is also the number of moles of solute. So the first part is the same, but the second part is different. This is dissolved in 1 kilogram of solvent. So see a difference over here. One is using the volume of solution. The other is using the mass of solvent. Alright? So you have to be aware of these. Now, if you need a recap, a solute mixed with a solvent creates a solution. Alright? So, these are the definitions for molarity and molality respectively. You just have to be aware the first part is the same, which is both using the number of moles of solute. But it's just one uses volume of solution, the other uses the mass of solvent. So, how about what are its meaning? So their meanings, you can take a look at them in different perspectives, right? So of course, molarity. Let's think about what is so special about finding the number of moles of solute in the volume of solution. So if you can think about it, it is technically numerical density, right? Since this is a density using this volume of solution, right? And numerical as in finding the number of moles, right? So technically you can take a look at it as a numerical density. So what else are there other than numerical density? Now it's mainly about density, since you have this dissolved in a certain volume, and if you know the definition of density, you would be quick to understand it. In other words, what if we multiply this part by its molar mass? So if you multiply it by its molar mass, of course you will get the mass of solute. But what's so special about that? So then it will give you a mass density, which they can do it during tests at times. Like, let's say they give you the mass of solute and they give you the volume solution. So the mass of solute, of course, if you're given a mass of solute and you want to find the molarity, then you just divide the mass of solute by its molar mass. So this mass density, it has become, in that volume of solution, how much of it, or should I say, what mass of it is solute, alright? So for molarity, you can define it in, or you can understand it in these two different ways, depending on what you get. Of course, sometimes it is the number of moles, sometimes it is the mass. So how about molality? Now, is molality density? Well, this is the mass of solvent. So it doesn't really seem like a density, right? Since you don't normally have density divided by kilograms, you don't really see that. So what exactly can you understand this as? So, of course, again, you can take it as numerical something. So, when you dissolve this amount of solute in solvent, you can take it as solubility. Alright? So numerical solubility. So solubility as in this amount of solvent can dissolve this amount of solute. Alright? But of course, it is not necessary for your solution to be concentrated, or I mean saturated, alright? You can have a solution that is not saturated. You can have one that's super saturated depending on the different conditions. And you just find that number of moles of solute within the solvent. Beware, solvent. Which is why you can understand it as solubility, which is this amount of solvent can dissolve this amount of solute. Now what if, again, you multiply this by its molar mass? So that would become your mass, solubility. So what's so special about mass solubility? This has become a bit more easy to understand for some of you, as it is now the mass of solute that is dissolved in a mass of solvent. So let's say you have 1 kg of water and 1 kg of sugar, and then you mix them together. So then you just divide them and divide by the molar mass of sugar and find its molality, alright? So both of these can have a numerical form and can have a mass form, but for molarity it is more about density, and for molality it is more about solubility, alright? So these are pretty much the meanings that they have. Now, symbol and unit. So from here, M, the capital M and small m, are, you can say that they're its symbols, why not? So one way to say it is M and M. Well, of course, one is capital, one is small. And how about its unit? Now, this is number of moles of solute dissolved in 1 liter of solution, which you would have the number of moles of solute, if you want to write it out, and this is over one liter of solution. So this unit, it is technically moles per liter, or depending on how you like to write the liter. So mole per liter, or you could just represent it as a capital M. While for molality, this is number of moles of solute divided by 1 kilogram of solvent, which here it can be mole per kilogram, or you could just represent it as a small m. So of course, beware, this is number of moles in 1 liter of solution. But if you want, like, let's say you have 2 liters of solution, of course you don't use the overall number of moles. If you want to use the overall number of moles of solute, then you have to use the 2 liters of solution, like as I previously said. So if you want the overall, or you're only given the overall, then it is overall number of moles of solute over the overall volume of solution. Okay? Well, same goes for this part, which it's either both of them, you take 1 kilogram of solvent that can have this amount of solute, or you just take the overall amount of mass and overall number of moles within the solution that you have, okay? So, the chemical category, both of these can be put in. Now, for molarity, what do you say for, let's say, a solution? So you would say a molar solution, okay? So a molar solution, which then you would have, like, let's say, the molarity of whatever you have within the solution. Or you can also say the molarity of the solution. Alright? So molar solution, or your molarity of the solution that you have. Alright. So same goes for molality. Now for molality, of course, there will be a bit of spelling difference, where you have molar solution and molality of solution. Alright, so these are what you can put them each into. So I hope from this you are more clear of what is molarity and what is molality, when do you use them, and what's so different about them. Alright, so we'll proceed to look at this example that we have over here, where we're supposed to find the molarity of 21.4. Well, beware, that is a small m, which is molality. So molar. Now HF, what is it? So you might know 2 different ways to say it, whether it's hydrogen fluoride or hydrofluoric acid. But in this case, how do we say it? Well, in this case, it is hydrogen fluoride. This aqueous solution has a density of 1.101 gram per milliliter, okay? So now you might be wondering, why is it hydrogen fluoride instead of hydrofluoric acid? So you have to be aware, hydrofluoric acid is the aqueous form. Alright? So since that is the aqueous form you have, now what if you have this as an aqueous form? That means you will have 21.4 molar of both your hydrogen fluoride and your water, which forms the hydrofluoric acid. But here it is only hydrogen fluoride, which is why you say hydrogen fluoride over there. Alright, so in this case we need to change your molality into molarity. Now we can think about it. What do we need to calculate molarity, what we have and what we don't have? So the similarity, both of them have number of moles of solute in the numerator. Now we just need to change the denominator of molality from your mass into your volume. but only that, beware, this is a mass of solvent. So of course you would have to think about how would your solute affect its volume and all, right? So that comes your problem. Alright. So first of all, we are given your density and we are also given your molality. Now how do we find, let's say, the number of moles weight? We need to start with an assumption, alright? So of course an assumption is, well, something that we're not given here. It doesn't really matter, but it will help us a lot. So what can we assume first? So firstly, we can assume that we have now, let's see, this aqueous solution. So we know there's water inside, but we don't know how much water, but it doesn't really matter. So let's say we just have 1 liter of H2O, alright? So 1 liter of H2O, or 1000 milliliter of H2O, or 1 kg, or 1000 grams, however you like to write it. So here we have 1 liter of H2O. So 1 liter of H2O, that means it is 1 kilogram of solvent. So how many moles of solute would we have? We would have 21.4 mole within 1 liter of H2O. Alright? So we have 21.4 moles of hydrogen fluoride. So what else would we have over here, or what else can you think of that we would need or would help us to solve? Of course, we can take a look at the density. What's so special about this density that we have? This density is of your overall solution, right? But how much solution do we have exactly? If you try to add up, it doesn't seem exactly right. So let's say we can find the mass of HF to help. So since you have a mass and H2O, we already know its mass, which is 1 kg, then we could use those information to find how much exactly do we have over here. So what is your mass of your hydrogen fluoride? Well, that is 21.4 times your molar mass of hydrogen fluoride, which is 20.01. Well, you can go and find out why if you want, which is just add the mass of hydrogen and fluorine. Okay, so what would this give us? So this gives us 428.21 grams. Right, so this is what we have over here. Now how about let's find your mass of your solution. So overall mass of solution. This is, you have 1 liter of H2O. That means you have 1000 grams of H2O. So that means you have 1428.21 grams of solution. Now let's take a look at it. Does this density finally come in use, since we thought of using a density, but of course you have to find the mass of a few different things before we can find your overall mass of solution, which then you can use your density. So that means now you can find your volume of solution. So this would be your mass divided by your density. Oops, I have an extra point over here. Alright, so we can now calculate this out. 1428.21 divided by 1.101. But beware, this answer you get here would be in milliliters, okay? So this is 1297.19 milliliters, or if you want to change it to liters, that will be 1.297. But now let's take a look at molarity. Molarity, we need 1 liter of solution, moles per liters. So can we use milliliters over there? Of course, if you want to convert later, yes you can. But you can also choose to convert now if you want. Which if you convert right now, so taking note of your different SFs, you can have this form of it, alright? So this is what you have for your volume of solution. Next, we have the moles of solute over here. We have your volume of solution. So this is overall volume of solution and overall number of moles of hydrogen fluoride, which then to find the molarity, of hydrogen fluoride, this is your number of moles, 21.4, divided by your volume. And what would this give you? So this gives us 16.497. So we could change that into 16.5 capital M, and here we put 3 SF, right? So this is our molarity of hydrogen fluoride, right? So as long as you know what you need to find and how you need to find, it's pretty simple, right? Of course, if you want a little more background information on this hydrogen fluoride thing, you can go search on your own. But generally what you would know, or what you would have learned, is normally it is a gas, and you can dissolve it in water to form your aqueous solution of hydrofluoric acid, which is a pretty strong acid. It is stronger than your normal hydrochloric acid, alright? But this molarity over here, it seems pretty concentrated, would you say? Alright, so of course, that will be all for this lesson of physical chemistry, where we compared two different types of concentrations of solutions, namely molarity and molality, right? So once again, molarity, you have your number of moles of solute dissolved in your volume of solution. While for molality, it is number of moles of solute dissolved in the mass of solvent. So you have to take note of those two differences. But of course, these are only two of the types of concentrations. Of course, there are a lot more other types of concentrations which we would explain in the future. So stay tuned, and I'll be ending this lesson over here. Thank you for your watching.